What if your Arduino could notice someone getting close without touching anything? No buttons, no pressure sensors, just light. That is exactly what we are building today. Welcome to lesson 15 of our 24-part series called Arduino for Beginners. In this lesson, you'll learn how an infrared switch sensor works, how to use it with Arduino, and how to turn it into a simple but realistic alarm system. This is one of those sensors that looks intimidating at first, but once you understand the idea behind it, it becomes incredibly simple and very useful. So let's get started. Let's take a look at the infrared sensor switch. At first glance, you might notice that this sensor is a bit bigger than some of the ones we've used so far. But don't worry, bigger doesn't mean more complex. In fact, this sensor is conceptually simpler than many others. This module has 3 wires. The brown wire is the power supply and should be connected to 5 volts. The blue wire goes to GND, and the black wire is the signal output, which will be connected to a digital pin on the Arduino. That's it. No extra components, no calibration code, no libraries. According to the official documentation, the recommended detected range is between 10 and 80 centimeters. In practice, it can sometimes detect objects a little closer or farther, roughly from 3 to 90 centimeters, depending on the environment and the object being detected. Now let's understand how this sensor actually works. Inside this module, there are 2 main components, an infrared transmitter and an infrared receiver. The transmitter constantly emits infrared light. This is a type of light that we can't see with our eyes, but it behaves very similar to visible light. If there is no object in front of the sensor, this infrared light simply travels forward and never comes back. But when an object enters the detecting zone, part of that light bounces back toward the sensor. This reflected light is picked up by the infrared receiver. The amount of light that comes back depends on several factors: the distance to the object, the color of the object, and the surface type. However, and this is very important, the sensor does not measure distance. It doesn't matter how much light comes back. As long as some infrared light is detected, the sensor considers that an object is present. Because of that, this module behaves like a digital switch. Here's how this signal works. When no object is detected, the signal output stays high, around 4 volts. When an object is detected, the signal drops to low, 0. So, from the Arduino's point of view, this is just a digital input that changes state. A very good mental anchor here is to think of this sensor like an invisible tripwire made of light. When something crosses that invisible zone, the sensor reacts, but it doesn't care how far the object is, only that it's there. Because of this limitation, infrared switch sensors are perfect for obstacle detection in robots, simple alarms, automatic counters, presence detection. But they are not suitable if you need accurate distance measurements. We will solve that limitation in the next lesson when we talk about ultrasonic sensors, which are designed specifically to measure distance. For now, that is enough theory. Let's put this sensor to work. Before we build the project, I would like to take a moment to thank today's sponsor, GF Robot. GF Robot is one of the leading global providers of open source hardware for makers, students, and engineers. With over 15 years of experience, they've developed a wide range of high-quality products designed for learning and prototyping. Throughout this entire Arduino for Beginners series, I'm using the GF Robot Mind Plus Arduino Coding Kit. This kit includes the Arduino board, sensors, modules, and everything we need to follow along with every lesson. One of the reasons I like this kit so much is that it removes friction for beginners. Instead of worrying about compatibility or missing components, you can focus on what really matters, learning how things work. So if you want to follow this series more easily and get the most out of each lesson, I highly recommend checking out a kit like this. Thank you again to GF Robot for sponsoring this project and helping make STEAM education more accessible. Today's project is a simple alarm system. Whenever something gets close to the infrared sensor, the system will trigger an alarm sequence using LEDs. It's a very realistic example of how this type of sensor is used in real-world applications. For this project, you'll need Arduino Uno, input-output expansion shield, digital red LED module, digital blue LED module, infrared sensor switch and some connecting wires. Start by attaching the input-output expansion shield on top of the Arduino. Then make the following connections. Connect the infrared sensor to digital port 2, connect the red LED to digital port 3, connect the blue LED to digital port 4, and this is for the hardware. Simple and clean. Next, go to the GitHub repository for this series, the link is in the description below. Open the folder for lesson 15 and you'll find a file called Infrared Alarm System. Copy the code, paste it into your Arduino IDE and upload it to your board. Now observe what happens. When nothing is near the sensor, the system stays idle. As soon as an object enters the detecting zone, the alarm is triggered. The LEDs blink alternately for 2 seconds and then the system automatically resets and starts monitoring again. This is a simple project, but it already shows how powerful a basic digital sensor can be. Now let's walk through the code and understand what is happening. At the beginning of the sketch, we define a few variables to store the pin numbers for the sensor and the LEDs. This makes the code easier to read and easier to modify later. Inside the setup function, we configure the sensor pin as an input, the LED pins as output. It tells the Arduino which pins it should read from and which pins it should control. Inside the loop function, the Arduino constantly checks the state of the sensor pin using digital read. Here's the key idea. If the sensor output is low, that means an object has been detected. When that happens, the code calls a function called trigger_alarm. This function contains a for loop that turns the red and blue LEDs on and off alternately for about 2 seconds. Using a function here is intentional. It keeps the main loop clean and makes the alarm behavior easy to expand later. After the alarm sequence finishes, both LEDs are turned off and the program naturally goes back to monitoring the sensor again. A good exercise here is to think about how you could extend this project. Add a buzzer for sound, add a button to manually reset the alarm, or change the blinking parter. Since we've already worked with these modules in previous lessons, I highly recommend you try implementing one of these upgrades yourself. Think of it as homework. Before we wrap up, I have an important announcement. I'm currently working on a drone building masterclass where we'll go far beyond beginner level projects. In this masterclass, we will cover topics like flight control, wireless communication, and even PCB design. This won't be aimed at completely beginners, but if you've been following this series and want to take the next step, it's a natural progression. If this sounds interesting to you, I've created a waiting list and you'll find the link in the description below. Signing up doesn't commit you to anything, it just ensures you will be the first to know when the masterclass is available. And that's it for today's lesson. You now understand how an infrared switch sensor works, when to use it, and just as importantly, when not to use it. If you enjoyed this lesson, make sure to subscribe so you don't miss the next one. And feel free to leave a comment below as I'd like to know what you think about this series so far. Before you go, I also recommend watching the video that's appearing on your screen right now. It builds directly on what we learned today and will help you continue improving your maker skills. Thanks a lot for watching to the end, and I'll see you in the next lesson.